Okay guys, here in this video what we're going to do is we're going to go ahead and set up BGP, and we're going to take a look at the essentially third step, well depending on how you look at it, could be four, the third step in our BGP best path selection process, and that's going to be the locally originated routes. Okay, now in this video what we want to do is we want to set up our network as follows. We're going to use ASN1 over here on R1, we're going to use ASN3 over here on R3, we're going to use ASN2 over here on R2. The reason I'm doing that is just to get around a route reflector. I just want to be able to have my updates fully going in on between my devices. Okay, so on R3, actually on all devices, we're going to go ahead and we're going to say redistribute connected, because we just want all of these routes, all of these interfaces, all these prefixes that we have, including our loopbacks, to go ahead and get advertised into BGP. But just like before, what we're going to do is we're going to keep an eye on this 102435 prefix. Okay. Now, in theory, what we should see is we should see R2 get chosen as our next hop in order to get to this particular network segment, right? That's shared between R2 and 3. So in theory, when we go ahead and send a packet to 1024.35.3, which is this interface over here, we should see that packet traverse through R2, come through the switch, and then hit over at R3. However, what we want to do is, using locally originated as essentially an attribute, if you will, we want to go ahead and tweak that best path selection process. So remember, we have N, Willa, Omni, right? So we have, is the next hop reachable, we have the weight, we have the local preference, and then we have the locally originated routes. So we've already messed with the weight and the local preference. Here we're going to set this up from scratch, and we're going to leave everything set to the default. So in theory, what's going to happen is we're going to get, is the next hop reachable? Yes, it is. Is the weight tweaked? No, it's the same. Is the local preference tweaked? No, it's exactly the same. Okay, which is a locally originated route? So as we do this, remember that anytime we see the network command or we have redistribution going on, we are going to prefer that over an aggregate address. So anytime we see an ag address, or essentially a summary address, which we're going to send down from R2, we are going to prefer either the network command or the redistributed address over this summary or aggregate address is what we call it in BGP. Okay, so let's go ahead and let's actually set this up. So just like in previous videos, I should have my IP routes, my static routes already set up. Again, I realize in some exams they're never going to allow you to do static routing, but at this point, we're just doing it for ease, right? We want to concentrate on the locally originated, not necessarily that I'm running OSPF on top of this and blah blah blah. We really just want to focus on this one feature. So I should be able to ping this. So if I say ping 2.2.2 source loopback 0, we're good. Ping 3.3.3 source loopback 0, we're good. So let's go into config. Let's actually set up router BGP. We're going to say 1 BGP router ID 1.1.1. We're going to say neighbor 2.2.2, and the remote AS is going to be 2 neighbor 2.2.2 update source L0 neighbor 2.2.2, and come on, and I'm going to say eBGP multi-hop. And again, if I just hit enter here, that's going to allow me to have a maximum of 255. I'm just doing that because obviously it's a requirement, right? Now let's go ahead and let's set up 3.3.3. 3.3.3 update source loopback 0 neighbor 3.3.3, and I'm going to say eBGP multi-hop. Go ahead and hit enter. Do show run section router BGP. And my configuration looks pretty good. So what we're going to do first on all devices is go ahead and redistribute connected, and we're going to see what the next hop is, what the best hop is, and essentially how we're sending traffic. So let's say config T, and we're going to say router BGP 3, BGP router ID, whoops. What's going on with my typing here this morning? There we go. Neighbor 1.1.1, still making mistakes left and right. Maybe I should go get some more sleep here. Remote AS is 1, neighbor 1.1.1, update source, loopback 0, neighbor 1.1.1, eBGP multi-hop, redistribute connected. Okay, so we're good there. Let's head over to 2, and let's wake them up. Config T, router BGP 2, BGP router ID 2.2.2. Let's actually just say redistribute connected now while we're here. Neighbor 1.1.1. Remote AS1, neighbor 1.1.1, update source, loopback 0, neighbor 1.1.1, eBGP multi-hop. So we should see adjacency come up. That's good news. Let's go check. Let's say do show IP BGP summary, and we have not received anything yet, which is okay. We know that BGP is not the fastest routing protocol on planet Earth, so we know that we're going to have to wait a few minutes here, a couple seconds, right? Really. So we have an adjacency that's up and running. We can see that. We see both our neighbors. We see that we have a 0 for in and out, so we know that things are going to be okay. All right. Now, if I go over to R3 and I say do show IP interface brief E assigned, we can see here that I just want to show you guys the networks that you're going to see in the routing table or in the BGP table over on R1. You're going to see, or we should see, these 3 loopback addresses from R3. We should see these interfaces here in our BGP table. Of course, this one is going to get added to the routing table. This one will not, because it's the interface here between R1 and 3. This one will not. It should be in rib failure because he's the loopback 0. We have a static route already in the routing table of R1. And again, this is the network that we're concerned about. Same thing if we head over to R2, do show IP interface brief E assigned. We should see the same basic thing here. So this interface here, which is in between R1 and 2, we should see in rib failure. This guy we should see added into the routing table. This guy should be in rib failure. These 3 guys we should see added into the routing table. We should see them as valid and best. And again, this is the network that we're going to be concerned about. This is what we want to see. So let's head back over to R1. And in the time of me blabbling, babbling or blabbling, whatever you want to say, we've gone ahead and we see prefixes. So let's say show IP BGP, and let's take a look at what we have. So we did see R3 chosen as the next hop. That's okay. So let's go ahead and let's see exactly what's going on here. So if I say do trace, and we go ahead and we pick 1024.35, and let's say 2, we go through R3, right? If we go and we take a look at how do we get to 10.24.35.3, obviously we go directly to 3. So at this point, R3 has been chosen as our next hop. So what we're going to do is, instead of sending the summary down on R2, I actually configured it backwards. I should have done 2 first. And so what we'll do is, instead of sending the aggregate address down from 2, what we'll do is we'll send it from 3, because 3 has been chosen as essentially our next hop. And we'll go ahead and flip this over to 2 by sending an aggregate address from 3. So I'm going to use the command aggregate address, and what I'm going to do is just say 10.0.0.0, and after this I need to go ahead and send the mask, so I'm going to say just a slash 8, and now what I'm going to do is I'm going to say summary only, just to make sure that I send the summary, just this summary. I don't want to send all the individual prefixes, because what will happen if I leave this off, what's going to happen is that R3 will still advertise this more specific network as well as the summary, and I don't want that. In order to flip this over, I need R3 to just advertise this summary. We should still see in theory all of these prefixes, but I want R3 again to just send this summary for this network, so that R2 is sending the more specific. All right, so let's say do show IP BGP, and let's see if we have to clear our neighbor table, and we don't. And so let's say do show IP BGP, and when we scroll down, just to prove a point, we still see the 3 prefixes from R3. That's good news. But take a look at what's going on now. So now we see that we have a summary route for the 10/8 network coming from R3. But if you look down here, the 10.24.35, the best and valid next hop, is now R2, right? So in theory now, let me control C out of here. If I say trace, and let's just pick 10.10.10, right? If I say trace to 10.10.10, I go to R3, right? Because I'm receiving a summary route from R3 that says, hey, if you need to get to anything in the 10 subnet, come to me. And so if I just go to, this prefix doesn't exist. If I make it up and try to perform a trace to it, I'm going to go to R3. So 10.133 is this interface right here, okay? However, let's try to ping a prefix that's in the 10, or let's try to trace to 10.24.35. So we'll say trace 10.24.35, and let's actually pick R3. And if I go ahead and hit enter, you can see that I went to the interface of R2, 10.1.2, and then 2, and then I looped back around through the switch, and I hit 10.24.35.3. So using that aggregate address, using that summary, we've gone ahead and we've flipped who's going to be our best pass. So show IP BGP. And the reason why, again, that this is flipped over is because R2 is using redistribution. R2 could also be using the network command, and that one of those two commands is always going to be preferred over that summarization command. We could even, if we wanted to, let's go ahead and let's actually remove this. All right, let's just keep playing around here. We could remove this. Let's pop it back in, but let's get a little bit more specific. Let's even bring it down to the 24 network. So we'll say 1024, and we'll just give this a 255, right? So now we're going to go ahead and summarize the /16 network. Let's go ahead on R1 and see what happens. Let's say show IP BGP, and let's see if we get it. Let's say clear IP BGP star soft. Let's do the same thing on R3. Do clear IP BGP star soft. Let's check R1. And the reason why I did that is because when I removed the aggregate address, you can see here that we went back to the normal, we went back to the regular BGP table. Let's say show IP BGP. And let's take a look at what we have. Okay, so now you can see that I have a 1024.00/16, and the next hop is R3, right? Because remember, we're sending in that aggregate address from R3. So we're getting that summary address. But still, take a look here. If I want to go specifically to 1024.35/24, my next hop is going to be R2. So again, if I do a trace to 10.10.10.10, that made up subnet that doesn't exist, in theory, that's not going to work. We needed to go to, let's say, trace 10.24.10.10. It's going to go to R3, right? Because we received the summary in here from R3. So we go ahead and we try to go to R3 and we try to find the next hop. Of course, we can't because R3 has no idea who that is. But now if I do trace and I do 10.24.35.3, you can see that I go over to R2 because BGP is going to prefer the redistribution or the network command over that summarized or aggregate address. So, if you're in an exam or you're messing around in production and you somehow have to get, path preference working, but maybe you're not allowed to use wait or local preference, or if you're going to go in, this is another point that a lot of network engineers, we're always big on summarization, right? If you're going to go in and you're going to summarize a network, be aware that if you don't send a summary address maybe from both ends, the minute you do it from one router, BGP, depending on whether you're running external or internal, remember that external has a little bit longer of an advertised timer, or assuming you haven't tweaked it, R1 will flip over and pick the more specific route, in this case the more specific route being R2, because he prefers the network or the redistribution. So just be aware of that in production. You don't want to have a resume generating event, okay? All right guys, in the next video we're going to take a look at the AS path. See you then.